Okay, class, so today we're going to look at mixed and entire radicals and go back and forth between these two. So today's going to really tie a lot of things together with what we've been looking at so far. And hopefully it gives you some clarity and just builds on a strong foundation that we already have. So a couple of things, skills review, write the number 3 as a square. So if I have 3 and I am saying it is 3 squared, well, that's not true. How can I make that true? I can make it true if I cancel out this square, and I would cancel it out by doing the opposite, which is square rooting. Okay, so just a little trick there. What about the number 5? How would I write that as a cube? Well, I'd take the number 5 and I would cube it, but how would I cancel out the cube? Well, I would simply have to cube root it. I would have to do the opposite. You'll notice how the roof covers the top of the entire inside radical. Very important. Don't leave your radical uncovered. What about this one? Write 8 with an index of 5. So if this is 8 and my index is 5, what do I have to have? Well, in order to have the same value, I'd have to have the exponent of 5 because the opposites counteract each other and cancel out. All right, so using that idea, you can combine that here, go the other direction. Since our index is a 2, we will be looking for pairs, so we can take this out, and this simply equals 11. And here we have 3 of the same number, and our index is 3, so we can take that out and equal 9. Index is 4, we need 4 of the identical numbers, we can take it out, and the answer is 6. So that's kind of what we're looking at today, but we're going to go one step further, which we'll find out down below. So first of all, remember that you can rewrite this any way you want. So you can rewrite that as 3 times 2 times 5. Because it's a multiplication, it doesn't matter which order you put it in. Okay, and there is one more order as well, but I'm not going to bother writing it. So just to let you know, you can write it different ways. Okay, going forward, what is an entire radical? An entire radical, well, that's when you have everything inside your radical sign. So you'd have an index of x, or some number, and if we don't have an index, if it's blank, it would be an index of 2. And then we have y, and y is some number that is your radicand. Radicand, and the whole thing is called a radical. Okay, now if you have a mixed radical, well, what we have then is we would have w in front, and then we'd have our index of x, and we would then have y. And w is what we would call our coefficient. Okay, and we then of course have our index. As always, it's still in the same location, and we would also have our radicand. It'd be the same location. So what is a mixed radical? Well, for example, if it's like 3 root 4, this actually means 3 times root 4. It's kind of like 3x is 3 times x, except instead of x now, we simply have our radical. Okay? Any questions? Please ask. So we're going to now go back and forth. We're going to do what we call simplifying, okay? So simplifying is different than evaluating. When we're evaluating, okay, we'll take entire radical and we will try and move everything out. All right, this will give us an exact value. Oh, so what's the difference is simplifying or evaluating is going to give us a decimal answer. So if I'm looking at this and I say, okay, well, give me the square root of 2 to 3 decimals, then I would have to round, and that's a guess. Okay, or if I say square root of 20 square root, well, that's just a guess. It's not exact. But what we're going to do is give the exact value. Okay, so it's not going to be a decimal rounding or approximation, right? It's an approximation because it is rounded. And that doesn't make it accurate. Good. So index, remember we have an index of 3. We're looking for groups of 3, index of 7, groups of 7. So first of all, we're going to rewrite this using prime factorization. And then we're going to look for groups, and of course we're going to remove the number. Now there's other ways of doing this, and I'll show you that later, but this method is going to work for all our hard examples. So if we have 240, we'll divide by 2, and we'll get 120, divide by 2, and we get 60, divide by 2, and we get 30, divide by 2, and we get 15, divide by 3, and we get 5. So this can equal then, okay, it's the exact same as all of this stuff. 2 times 2 times 2 times 2 times 3 times 5. And so then we would look for groups of 2 because our index is a 2. Okay, we don't write it, that means it's a 2. So here's a group of 2, that can come out. Here's a group of 2, that can come out. So this 2 times 2 is on the outside, and what's left over is 3 times 5. Okay, we can only take out the 2 times 2. And so then what we're going to do now is regroup them. So we'll simplify it, and we'll get our answer of 4 root 15. There you go. That is simplest form of root 240. We can take out a 4, and we have root 15 left over. Let's practice this next one. Root 48. Okay, so divide by 2. We get 2, 4, 1, 2, divide by 2, we get 6, divide by 2, we get 3. So root 48 equals square root 2 times 2 times 2 times 2 times 3. And again, our index is a 2. That's where we're looking, right there. And so we can take out a group of 2 and another group of 2. And these are still being multiplied together just like they are on the inside. And we got a lone wolf left over, 3. And so our final answer then, when we combine these back together and regroup them, is 4 times root 3. Okay, so on your calculator, this would be 4 times root 3, and then you would find the value of it. All right. Number 3, it's done. No, it's not done. Okay, this is not finished. So you're going to get a question on a quiz or a test, and it's not finished yet. It's not in simplest form. So we have to simplify it. So let's just ignore the 3 for now and work on the 32. So here I have my 32, divide by 2, 16, divide by 2. Finish it, go. So you should have pressed pause. I hope you did. Remember, math's not a spectator sport. Do your work. And so I'm going to get 3 root 32 equals square root 1, 2, 3, 4, 5. Now, I have 3 in front, so that just drops down as the part of the multiplication. It's being multiplied here, right? That's a multiplication. And so when I rewrite it, it's still multiplying by the numbers that I take out. So I will take out a group of 2, and I'll take out another group of 2, and I have one too many, my bad, sorry, and there's one guy left over. So this one left over is right there. Now we got to regroup it, and 3 times 2 is 6, times 2 is 12, so my answer is 12 root 2. Simplest form. Okay, sometimes it might not be simplified all the way and you need to finish the question. All right, here we go. Root 42, do it on your own right now. Press pause and do it. Do it. Let's go. Practice. Okay, here we go. 42, I'm going to divide by 2. I had 21, divide by 3, and I get 7. That's weird. Did I screw something up? Let's see. 42 divided by 2. No, divide by 3. Yep. Guess what? So this equals 2 times 3 times 7. Can you take anything out? No. So then you just regroup it, and it is the simplest form. Okay? Now, if you leave this blank, you ain't getting full marks. You need to show me that you know that that is the answer, that it's in simplest form. So you got to make sure you write the answer down. Okay, going on then. Next one, 256. You try it. Go for it. 256 divided by 2. Come on, let's go. Do it, do it, do it. Just do it. Okay. Wait, so divide by 2. Oh, sorry, it's too late at night. Oops. 128 divided by 2, 64 divided by 2, 32 divided by 2, divided by 2, 8, 4 divided by 2, 2. Man, that's a lot. So, you know what? How about I look here for pairs? Rather than rewrite it, I'm just getting tired of that. So, if you don't understand the concept, this isn't going to make sense. But if you do understand the concept, you can just simply show your work this way. And then you can say that this equals 256 equals 2 times 2 is 4 times 2 is 8 times 2 is 16. Okay, but really, you got to make sure that you understand this is what we're doing, and that's how you're getting this answer. Okay. Next one, cube root 24. So this is different. So let's factorize this thing. Divided by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. So this equals a cube root. This is really important. $10 as you forget that on a quiz. Super important, gotta have it. I will take marks off. Make sure roof covers everything. And so now we're looking for a triple, so we can take out a single 2. So this 2 goes on the outside, and we still have cube root 3 remaining. Final answer. Okay, here's some more to practice. So you can practice on your own. I'm just going to pause this and show the answers because I think that you guys can kind of see what to do here. But I will show the answers just so that you can check. Okay? Okay, so the index is a 3, so we're looking for groups of 3. So here is a group of 3. Boop. Here is a group of 3. Boop. Here is a group of 3. So this one is a perfect cube. So cube root 512 equals 2 times 2 times 2, which equals 8. I need to double check that because I think I screwed up. Nope, I didn't screw up. That's the right answer. Okay, so this one here, I do the division, and so I have looking for triples. There is a triple. I take out a single value of 2. There is a triple, single value of 3, but this one is remaining. So, keeping that in mind, that one's remaining. I'm going to get 2 times 3 on the outside, cube root 2 on the inside, so 6 cube root 2. There's my answer. Okay, so number 9, when I factorize it, I have these 3's right here, which are, there's 4 of them, so I can take out a single 3. So I have 3 fourth root of 5. Now be careful, that 3 is almost looking like it's raised up. It should be just as big as this guy is. Okay, next one. This one's a little tricky. So I'm going to just rearrange this multiplication a little bit to make it easier so you can see it. So what we can do is we can have a cubed times b cubed times b, because that would be b4, okay? And then for the c, we would go times c3 times c3, that's 6 times c. So what we can do now, here's 3 of them, we can take out a single a. Here's 3 of them, we can take out a single b. Here is a single c, here is a single c. So we're left with on the outside A times B times C times C. And what's left over? Cube root B. Okay, so we're going to finish off this question here. We have to regroup things back together. So we're going to get A, B, C squared, cube root B, C. There we go. Now, some people, when they're really good, they can recognize from here that you have to take away groups of 3. So you can take out a group of 3. You can take out a group of 3, but there will be a B left over. You can take out 2 groups of 3. See the exponent 2 there? 2 groups of 3, so you'd have exponent 2, and there would be a C left over. So then you're going to get A, B, C squared, cube root BC. Okay, that's pretty upper end. So only if you watch this, and I'm going to show it to you, I will erase this, but there you go. Have a quick look at it before it's gone. Moving forward then, what about going the other direction? So now we have a mixed radical. We're starting with the mixed radical with the 3 on the outside, and we have to move it in on the inside. So what we have to do, remember here, with the index of 3, when we bring something inside, we would have to have 3 of them. So here our index is a 2 index. And so when we bring the 3 inside, it becomes 3 times 3 times 2. You could have that in any order if you want. You could go 2 times 3 times 3. That's fine as well. But there's no use kind of splitting it up and putting the 2 in the middle. So then you get square root 9 times 2, and then you get square root 18, final answer. Of course, you can go straight there. Okay, try the next 2, see if you got it right. I bet you have. Cube root what? Go for it, do it, do it, do it, do it. 2 times 2 times 2 times 5, which would be 2 times 2 is 4 times 2 is 8 times 5, cube root 40. Okay, next one, 4th root. So you gotta have 4 of them. This one's going to be large. Mr. Barker's going to cheat and use his calculator. You should have done this already. If you didn't, shame on you. You're not really learning. 4th root of what? Go to my calculator. 4 times 4 times 4 times 4 times 3. 768. Okay. There we go. So you're going to convert going from a mixed to an entire radical by bringing numbers inside. Next, we already touched about this a little bit about estimating their roots and where they are in their location. So we're going to do this one more. First thing is you got to bring it inside your radical. So this would be square root 7 times 7 times 2. So that would be square root 49 times 2, which would be 98. Here, bring the 4 inside, so square root 4 times 4 times 6. And so you're going to get 16 times 6. Ooh, you know what? I'm going to do it this way. 4 times 6 is 24. 24 times 4, that would be 16. So 96. Okay. And then 6 root 3. So bring the 6 inside, square root 6 times 6, which is 36 times 3. So 36 times 3, 18 and 1, 9, 10, 108. So when you have it all inside, you can compare them easily. Which one's smaller, which one's bigger. So right away, I can see that the smallest one is B. Okay, this one's the smallest. Then what's next after B would be A. So that's going to be this one right here. And then what's after B? Well, after A would be C, the largest one, because it's the larger. So right away, you can compare these to each other just by looking at the size of the radicand. Okay, so we have B, A, C. The question is, where do those fit in? So let's go and check this out. We got to find estimation of one of these. let's do the very first one. So perfect square above would be root 100, which equals 10. Then I know that this one would be 9, so this would be square root 81. And I'm really close here, right? I'm only 4 away, so probably like what, 9.8 or something like that. This one here is a little bit above 10, so maybe it's like 10.2 or 10.1, something like that. And this one is a little bit more, so maybe this one here is 9.9. Okay, so again, you could do it individually, might have more success. But what we want to do now is compare to this one. So this one here would be the fourth root of fourth root of 2 times 2 times 2 times 2 times 10. 2 times 2 is 4, times 2 is 8, times 2 is 16. So fourth root of 160. This will be the cube root of 2 times 2 times 2 times 10. What is that? Cube root of 2 times 2 is 4, times 2, 8, 80. So we got to kind of figure out cube root 80, whereabouts is that? And fourth root of 160. Okay, so fourth root of 160. So we got to think about cubes. So we got 1 cubed equals 1, 2 cubed equals 8, 3 cubed equals 27, 4 cubed equals 64, getting close, 5 cubed equals 125. Bingo, right there. So which one is above? Well, cube root of 125 equals 5. And then cube root of 64 equals 4. So whereabouts are we? Well, we are quite a ways from that, and we are only, this would be 45 away. What would this one be away from the bottom one? 70 would be 6, so it would be 16. So we're probably at somewhat like 4.3 maybe. Okay. Good. Fourth roots. Let's go to the exponent 4. What is that? 2 times 2 is 4, times 2 is 8, times 2 is 16. And then let's go maybe 4. What's 64 times 4? It's fourth root of 4. 36. Y, 4 times 6 is 24, 25, 256. Okay, so I'm way over there. And what's the 3 to the exponent of 4? 81. So I'm right in between these two right here. So the fourth root, let me get my blue pen. Fourth root of 256 equals 4. And the fourth root of 81 equals 3. So I'm going to be somewhere between 3 and 4. Do I really need to know? Nope. Don't need to know. Why? Because I know right away that it's going to be the smallest one, right? It's between 3 and 4. The other ones are all above that. So then E goes first, and then we have D, which is above 4, 4.3, and then we have the other ones. Okay, so really what I did is I compared these to each other, but then I realized that they were a lot smaller, and these ones were a lot larger. These three were easy to compare to each other because they all had the same index. Okay, so same index, then you just compare radicands. All right, when you have a different index, then you got to go more carefully into your estimation. Okay, that's it. Enjoy.